record section. Okay. Let's understand on where I'm going to use hub, switch, or router. Okay. So hubs normally used to connect same network devices. Switches are also used to connect same network devices. Routers are used to connect different network devices. So when I say different network or same network, now it's a high chance that you may not be able to understand what I'm saying. But when I talk about IP addressing and subnetting, you'll understand this topic. Okay. So as of now, just keep this image in your mind that switches and hubs are used to connect same network devices. Routers are used to connect different network devices. Let's talk about Soho. Soho expands to small office, home office LANs. Again, it is not a technical term, technical topic. It's a normal topic that talks about how you are able to connect internet from your house. So probably if you ask Namrata how you're able to join your Wi-Fi network, the answer will be from her laptop. It's connected over a Wi-Fi to her Wi-Fi router in the house. The router goes to the internet. That's as simple, right? So mobile phone again connected over a Wi-Fi to the router, then router to the internet. So what if I have 5 computers? What if I have 5 physical computers and I want to connect to the internet? So do I have 5 ports first of all in the router? No, I don't have 5 ports. I just have 2 usable ports in yellow color. So I have to have use switch. So basically I'll be connecting 5 computers to 5 switch ports. From this switch port, I will take one connection. I'll go to the router, from router to the internet. So I'll be connecting 5 computers like this. 1, 2, 3, 4, 5. So this is called small office, home office LAN setup. How we connect our computers to the internet. So it's very simple. So 5 PCs, switches, then router, then internet. Let's talk about Ethernet cables. As I told you, this chapter itself, chapter name is what? Ethernet, fundamentals of Ethernet LAN, which means we're going to talk about more about LANs, right? I talked about what is network, what is protocol. I told we have 3 different types of LANs: Ethernet LAN, fiber LAN, wireless LAN. We have a separate chapter for wireless LAN in future, so we can skip it as of now. It is not in the book also. We'll talk about Ethernet LAN and fiber LAN now. So to understand Ethernet LAN, you should understand first of all what is this term called Ethernet, right? Ethernet is basically a technology name which uses copper cables, which has like 4 pairs or 8 wires of copper cables are being used to send and receive data traffic in the internet or between computers. Now, Ethernet cable was introduced by IEEE, Institute of Electrical and Electronics Engineering. IEEE introduced this particular Ethernet cable. Now, Ethernet cables are the physical devices or physical cables which are used to connect 2 or more devices together. Okay, so the first ever cable which was introduced by IEEE was named as Ethernet, which is the same name as your technology name. So I hope you know the name of Xerox story, right? Xerox is actually a company name. Now these days we have replaced the term photocopy with Xerox because this brand became very big. Similar to that, you can think Ethernet was technology name. The first cable introduced by IEEE under Ethernet technology is also termed as Ethernet. Then in future, if they discovered something called fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet. Now to understand simply, Ethernet means 10 Mbps. Fast Ethernet means 100 Mbps. Gigabit Ethernet means 1000 Mbps. 10 gigabyte Ethernet means 10 Gbps. So Namrata, Bansi, Alan and Lingesh, you guys understand what is an Mbps means?
No.
Yeah. Others? Sandeep understands that. Bansi understands that. Again. So you know what is MB? MB means megabits per second. So you're using internet, right, Namrata? So when you buy the internet, they will give you something like 100 Mbps. They will say your internet will work at 100 MB of data download or upload in per second. This is the speed of internet which you're using. So Namrata, you're using Wi-Fi connection?
Yes.
Okay. Who pays the bill?
My husband.
Who bought Wi-Fi? Probably him. That's why I don't know about it. So basically, when you approach a ISP or internet service provider, they'll ask you first question: how much speed you want? You can tell he I want 100 Mbps or 500 Mbps or 1000 Mbps. To understand what is Mbps, I can tell you an MP3 song will be for 5 Mbps. A normal movie, a 3 hours movie or 2 hours movie will be for 500 Mbps, 500 MB, sorry, not PS and all. The size I'm saying. If I say HD movie, it will be like 2 GB, 2 gigabits. It is like 2 GB means 1 GB means 1000 Mbps, 1000 MB. Okay, just write it down if you don't know about it. So I can say mobile MP3 song will be for 5 MB, a normal movie will be 500 MB, a HD movie will be for 2 GB, and this is a comparison GB and MB. So 1 GB is equal to 1000 MB. Okay, so these are the common names given by IEEE. They said these things and they told okay. Now let's talk about the informal and formal IEEE standard name. So officially, when they wrote it on a paper, they have given a name. They have given informal and formal names. Most of us will be using these names only to represent these cables or these speeds. But as per notes or as per his notes, which IEEE wrote, it will be represented using these numbers. So when I say 10 base T, which means Ethernet cable, when I say 100 base T, which is fast Ethernet cable, 1000 base, here it is, sorry, 1000 base T, gigabit Ethernet, and 10 G base T means 10 gigabyte Ethernet. We can easily understand it actually. 10 base T means 10 means the speed, which is 10 Mbps, base means baseband, and T means twisted pair cable. Again here 100 means 100 Mbps baseband twisted pair cable, 1000 Mbps baseband twisted pair cable, 10 Gbps 10 Gbps, again it's called 10 gigabit baseband twisted pair cable. So Namrata, have you repaired any cables or wires in your house? Like have you used a 2-pin plug? Have you changed it in your
Yes.
house?
Yes.
So when you actually work on these 2-pin pin wire, the cable what you have, right? There will be 2 wires. One will be positive, negative, and they're always twisted. Have you watched them like this? It will be like this inside the insulation wire, right? The actual I'm talking about the plain electrical cable wires, which you normally see in your house.
Yes.
Yeah. So they're always twisted. But why? Why we have to twist it? So normally when you take a 1 meter, 2 1 meter wires and you twist it, it actually reduces the size of the wire, right? It won't be 1 meter anymore. It will be like maybe like it's 80 centimeters or maybe 90 centimeters. Why companies are twisting it? Which is a loss. when they twist it. The reason behind it is that when you have a positive and negative cables, and when they're twisted, these wires, when they pass electrical signals, they form some sort of electrical waves, right? They form some electrical waves, signals, and as they pass through, the wave keeps on going increasing like this. So we have two waves. So when I twist them, in the each twist, they cancel each other. The electromagnetic signals, electromagnetic waves, electrical waves, they cancel each other, and they again start, again cancel each other here. But when I don't twist them, if I lay down as it is, they cannot cancel each other. They go like this. Because of which the loss will be very high in the electrical wires. So just to make sure there is no crosstalk. Crosstalk is the technical term which we can use. Crosstalk is the technical term we can use. Reduce the crosstalk between two wires, we twist them, and it is applicable to lowest voltage possible to the highest voltage or highest current possible. So here also the T came because the Ethernet cables, they are in 4 pairs and they're always twisted to reduce the crosstalk. So more number of twists, which means good quality cables. We can see like that. Okay. So these are informal names. These are the formal names. Now I'll give you a dummy example of formal name. Dummy example. So Alan, what phone do you use?
Sorry, sir.
Which phone you're using? Phone.
iPhone, sir.
iPhone. Which model?
13 Pro, sir.
iPhone 13 Pro. Here you see something, right? What is
Yes,
so?
sir.
Are you aware of this number already? MLL
No,
93HN/A.
sir.
No. So this is the common name which Apple company gave. This is actually the model number. So whenever a company manufactures a new product, they always have a model number. Similar to that, IEEE also gives some model numbers. They always starts with 802. So 802.3 means they are representing the cable 10 Mbps. 802.3U means they're representing the fast Ethernet cable. 3AB means gigabit Ethernet, and AN means 10 gigabit Ethernet. Okay, that's what they told initially. Let me do one thing. Just hide it. Animation appears. Um, 1 minute. With entrance exit disappear. Okay. So initially we had Ethernet, fast Ethernet, gigabit Ethernet, and 10 gigabit Ethernet cables. They all look similar. They're all in same size. We can say it as. Here we have cable type, which will be 100 MB. Sorry, copper cable, copper cable, copper cable, copper cable, and the maximum distance they can travel is 100 meter. Okay, so the 100 meter is the maximum distance a copper cable can go. Now IEEE is in confusion. Hey, so we don't have any Ethernet cable which can cross beyond 100 MB. So as per the book also. So let's bring in one guy called 1000 base LX. See, it is not T here, it is LX. It says that it is not a copper cable, it is a fiber cable. They bought the fiber family guy into copper family guy. So they bought the fiber family cable to a copper family because it can travel up to 5 kilometers. So that we still call it as Ethernet, but Gigabyte Ethernet. Some people might have noticed, hey, there are 2000 Mbps by mistake. It's not by mistake. It is there because they said so. And they also given a technical number 802.3Z. Okay. So the good part is you don't remember all these numbers and all. Nobody will ask you. Nobody will ask you. These numbers these names you remember. That's enough. Okay. Great. So if somebody asks you a question, what is Ethernet? It is equal to what is 802.3. Both are same. Nothing differences between them. So far so good, everyone. Please type in chat okay or ask me any questions you have. We got 3 chats. One more chat I'm waiting for. I got 4 chats. Good. Great, thank you. Now let's see how they look like in the real time. The RJ45 is the name of the connectors we're going to use. This is called network interface card. This is called a LAN switch. RJ means radio jack, 45, nothing but a model number. It doesn't mean anything. NIC expands to network interface cards. So RJ45 cable goes inside this network interface cards. NIC cards will be there in the switches, or it is also there in the routers or hubs, even on the computer. So Namrata and Mansi, do you guys have network interface cards on your laptop? A port which is similar to this one? Okay, Bansi has it. How about Namrata? Yes. So that's called network interface card. Okay, NIC cards. And they are used to connect two computers. I told right we can connect two computers. How I can connect? I can connect using network interface cards using my Ethernet cable. Now, when I use Ethernet cable is made up of copper. So the communication is happening with the help of electrical signal, right? When I use fiber cable, what type of signals we are using?
Light signal, sir.
Correct. We're using light signal. So when I'm going to, Bansi, you're right. So imagine I have this port here. I'm going to put a fiber cable, basically. So when I put fiber cable, it has something called light signals. It has light inside it. And these component, what are these component? This is an IC. This is a capacitor. This is a resistor. So these components, they work on electrical signals. So when I pass light, do you guys think that it will work, this chipset? Right, it's almost equal to when you put torchlight on your TV, will it turn on? Exactly. No, it's not possible to turn on any electronic component, electronic devices with the help of light. So there must be a way to convert these light into electrical signals. Yes, I have to have a device to convert this light into electrical signals, and that device is named as SFP. The full form is named, both are weird, but use case is very simple. SFP, these are the SFP ports. They look like a rectangle, that's all simple. SFP expands to small form factor pluggable. And SFP is a device which is used to convert light into electrical signals. Very simple. And they always go inside the SFP port. Now, Let's talk about Ethernet cable types. We have two types of cable. One is called straight through cable and crossover cable. Straight through cable means I told we have 8 pins or 8 wires inside Ethernet cable, right? So when I say straight through, which means they are straight connected, like pin 1 goes to pin 1, 2 goes to 2, 3 goes to 3, 6 goes to 6. When I say crossover, they are slightly crossed. Pin 1 goes to pin 3, pin 2 goes to neighbor end, pin 6, pin 3 vice versa. Pin 3 goes to pin 1, 6 goes to 2. You can think multiplication of 3. It is one end of RJ45 cable, it is other end of RJ45 cable. So straight through cables are used to connect different devices, and crossover cables are used to connect same devices. Crossover cables are used to connect same devices. When I say straight through cables are used to connect different devices, which means I have a PC and a switch, I'll be using straight through cable. PC and router, straight through cable. Switch and router, straight through cable. Router and a switch, again straight through cable. But when I have same devices, I have to use crossover cable. Maybe PC to PC, it will be crossover cable. Let's have an understanding on why. Why is it like that? So imagine I have PC1 and it has something called network interface cards. It also has NIC card, network interface card. There are 2 pins. Imagine I have transmission pin, second is receiving pin, RX pin. Using transmission pin, I send traffic. Using receiving pin, I receive traffic. If I use straight through cable, what will happen? TX will connect to TX. So is it a right connection? Do you guys think is it right? If TX goes to TX and RS connects to RX? No, exactly. It's not right. Always like TX should go to RX. So if I use straight through cable for same devices, it is wrong. That's why I'm going to use crossover cable. So that TX will go to RX and this TX goes to this RX. Now it is right. Whatever I am sending, he should receive it. Whatever he is sending, I should receive it. That's the right answer. So we will be using crossover cable for same devices and straight through cable for different devices. Okay. Let me ask you a small quiz now. Okay. I have a PC. I want to connect to a switch. What cable I'll be using? Yeah. So you guys can answer with from question number 1. Yeah, correct. Straight through cable. Namrata, you. Why others are not answering? Alan, Lingesh. Answer for all these questions.
So first 2 is straight through cables, and last 2 are a crossover cable.
Yeah. Namrata, you.
First 2 is straight through cable, and 3 and 4 is a cross
Correct.
over cables.
Yeah, exactly. Okay, that was simple. Let's talk about the fiber cable. So fiber cables, they are simple. They are made up of glass pieces. Obviously not the window glass. They are called fiber glass. So they look like this. So have you guys went in boat? Any of you guys traveled in boat? Small boat, not the ship. Normally these boats, these fishermen use, they are made up of fiber strands. If you're careful note, you'll see these sort of particles pieces in that, and they will use some glue just to stick it all together. So they are also made up of fibers, fiber boats, they're called as. So this also you might have seen played everywhere they pass lights, right? So the fiberglass is made up of 5 different components, out of which the main component is core. So core is the central part where the light passes through. They go like this. They travel like this inside the core. Cladding is a small insulation which you provide over the core so that light should not come out of the core. Our focus is that the light should travel within core, not on cladding. Buffer, strengthener, and outer jacket, all three are different insulation materials which we normally use. Okay, let us try to get some images of these guys. Buffer in what is that? Topic name भूल गया मैं तो. Fiber. So here it is. You can see a white color, some cloth kind of thing that's called buffer. So when I say strengthener is the insulation kind of. It will be something like an insulation. What do you call it? As a plastic kind of thing. That will be strengthener. Strengthener. This kind of plastics will be there. These are called strengtheners. If you got a chance, you can go to a local shop, get a fiber cable for 1 meter, cut it and just check it out inside. What is there? Okay. So now in fiber, there are 2 types of communications. One is called single mode fiber and second one is called multi-mode fiber. When I say single mode fiber, it is like this. We'll be using a laser beam and a single type of traffic will be flowing within that core. When I say multi-mode, there will be a beam of light which will be flowing in multiple direction and we'll be using LED instead of laser. So multiple traffics can go in one shot when I use multi-mode. Single mode means single beam of traffic, and also the core will be thicker compared to this guy, single mode. So with that, we are completing your section 1 of CCNA volume 2. Sorry, CCNA volume 1, second chapter, not volume 2. Now let me. Okay, so with this, I think today is enough. We don't want to say any more technical things. We are good to complete the session. Tomorrow we'll be having lab. Tomorrow we'll talk about IP addressing. We'll talk about small labs on how to configure routers, switches and all. We'll configure. Now, and daily homework is very simple. Initially, we were giving homeworks, but it was not that efficient to manage like so many students with all the homeworks. So now we are plainly following book homeworks. So what you guys can do, simple. You guys can open your books. CCNA books. Open your books and go to fundamentals of Ethernet LAN. Sorry, I mean go to that chapter last page. Okay, where is it? I'll go to chapter number 3 and just go back reverse. So it is the fundamentals of LAN, last page. So here you can see there is no much homework or anything. So I think today there won't be any homework. This chapter review is that's all. A next chapter which you're going to talk about is fundamental of WAN IP addressing. Oh, I'm sorry, it is in the first. I'm sorry, I missed. So just open your book and go to chapter 2, fundamentals of Ethernet LAN. Okay, and here you see quizzes. First page, you see quiz question number 1, 2, 3. Just this will be your homework on every day. So every day we are going to cover based on your chapters. So here you have the questions which you have to answer. Today homework for you will be just try to answer these questions. And if you have any doubts while answering, just ask me. Okay. Okay. And today there is no lab because first chapter doesn't have any kind of labs. Okay, great. So if you guys have any doubts or question, please ask me now, or else we can end the meeting. The session recording will be shared to you guys over WhatsApp chat.
Sorry, just double check. We will gonna have a lab tomorrow, right?
Yes, from tomorrow there will be a lab session. Yes, make sure you just
Oh.
join using your laptop.
Okay, perfect. It'll be the same time, or the lab will be extra time.
No, it will be same time. 7:30, 9 o'clock Indian time zone. Yes.
Okay, thank you.
Yeah, no problem. So Alan, Bansi, and Lingesh, you guys have any doubts? No, Bansi told no. And I need your photographs. Every one of you guys in registration process, we are unable to send you that actual form because some people are from out and from India.